Hello, and welcome to this session on percentage. This is the first part. You can reach out to me via Twitter. My Twitter handle is @Ravi Handa. In today's session, we are going to talk about fractions and their equivalent percentages. We are also going to see how they come in handy or how they are useful. Let's look at them. See, the fraction of half is actually equivalent to 50%, which I guess you might know. Very similarly, one third is actually 33.33%, one fourth is 25%, 1 by 5 is 20%. In case you are wondering how am I calculating these values, well, if 1 or the total corresponds to 100, then what will 1 by 5 correspond to? It will correspond to 20%. How do I calculate 1 by 6? With a very similar logic, I can do 100 by 6, or I already have a one third as 33.33. Half of that will be 1/6 or 16.66%. 1 by 7 I'll have to calculate, comes out as 14.28. 1 by 8, well, once again, you have 1/4 as 25. 1 by 8 will be nothing else but half of that value, which is 12.5. Very similarly, 1 by 9, well, one third is 33.33. 1 by 9 will be one third of that, or 1 by 3 of 33.33. You will get, as you can see, 11.11. Very similarly, 1 by 10 corresponds to 10%. 1 by 11, you'll have to calculate, not a very difficult calculation, it'll be 9.09%. 1 by 12, well, once again, I recommend you take 1 by 6. 1 by 6 was 16.66. Half of that, half of 16 is 8. 0.66 is 0.33, which gives me 1 by 12 as 8.33. 1 by 13, once again, you'll have to calculate, comes out as 7.69. 1 by 14, you have 1 by 7 here, given to you as 14.28. Half of this, half of 14 is 7. 0.28 is 0.14. So 1 by 14 comes out as 7.14. 1 by 15, well, there are plenty of ways of doing this. You have a 1 by 5 as 20. One third of this is 6.66. You could have also done it as you have 1 by 3 as 33.33. You could have divided it by 5. Once again, would have led you to the same result as 6.66. Another important point is, where are these going to be useful, or why do I even need to know these percentages? Well, you need to know these percentages just so that you can calculate a little faster. You can't imagine how easy things will be if you have something like this. Let me take a rough example. Let's say you have to calculate 28.5% of 35. Now this looks like a difficult calculation, but if you know 1 by 7 is 14.28. So if 1 by 7 is 14.28, you can do this in your head. 2 by 7 will be roughly 28.56, and 28.56 is terribly close to 35, which means instead of calculating 28.5 of 35, you can simply calculate 2 by 7 of 35, which comes out as 10. Once you have the value of 10, look at the options. If there is an option which is 10 and the others are very, very far, well, your answer is 10. However, if there is an option like, let's say 9.98, there is 10.04 and stuff like that, your answer will be just less than 10. Why? Because 2 by 7 here, as you can see, is 28.56. So you have calculated 28.56 as 10. 28.5% will be little less than that. And that is how you can use these fractions that you have here and their equivalent percentages for easier and faster calculation. Hope that helps. With this, I'd like to wrap up this small session. Please provide feedback via Twitter at my Twitter handle @RaviHanda, or you can also get in touch with me at my mail ID, which is ravihanda@gmail.com. Thank you guys. Thanks a lot. To the part 2 of the percentage lesson. You can reach out to me on Twitter via my Twitter handle @RaviHanda. Today, we are going to talk about percentage change in directly proportional quantities, also in indirectly proportional quantities, and how can you nullify a particular percentage change. To begin with, let's say percentage change in directly proportional quantities. Suppose I am given two quantities P and Q, which are directly proportional to each other. What it means is if P doubles, Q doubles. If P becomes one third of the original, Q also becomes one third of the original. If P becomes 5 by 17 of the original, Q also becomes 5 by 17 of the original. Not a very difficult one to solve. In this case, if there is a percentage change, that is, if P grows by 10%, Q will also grow by 10%. If P falls by 17.22, Q falls by again 17.22. Whatever is the change in P, the same change will happen in Q. That is why they are directly proportional quantities. Whatever is the change in P, the same change will happen in Q. That is why they are directly proportional quantities. To continue, let us look at the percentage change in indirectly proportional quantities. Let's say P is inversely proportional to Q. Then what it means is if P doubles, Q halves. If P becomes one third of the original, then Q becomes thrice of the original. If P becomes 5 by 17 of the original, Q becomes 17 by 5 of the original. Now you might be thinking that if P grows by 10%, Q will fall by 10%, or if P falls by 17.22, Q will grow by 17.22. Well, if you are thinking that, let me tell you, you are wrong. This is incorrect. This is false. So if this is false, how do we actually solve it? Well, if P grows by 10%, it becomes 11 by 10 of the original because it has grown by 1 by 10 in a fraction. That means if P is becoming 11 by 10, Q will become 10 by 11 of the original, which means Q will fall by 1 by 11 or 9.09%. As you can see, Q is not falling by 10%. Let me take another example to clarify this idea. Let's say P falls by 25%, which means it becomes 3 by 4 of the original. If P is becoming 3 by 4 of the original, the quantity it is inversely proportional to, that is Q, that will become 4 by 3 of the original, which means it will increase by 1/3 or 33.33, which essentially leads to the idea that it will grow by 33.33%, which essentially leads to the idea that an R% change will lead to minus 100R by 100 plus R percentage change in indirectly or inversely proportional quantities. Please note this formula is very important. It will come in handy in various places. R percentage change leads to minus 100R upon 100 plus R percentage change. Try it out. Try it out with 10%. It was growing by 10%, which means R is plus 10. So this becomes 1000 by 110. 1000 by 110 is the same as 100 by 11 with a negative sign. 100 by 11 with a negative sign is minus 9.09%, or it has fallen by 9.09%. Try it out with the second case also. Let's say if R is falling by 25, so it is minus 25. Minus and this minus will cancel. You will be left with 2500 in the numerator and 100 plus 25 or 125 in the denominator. And how much is 2500 by 125? Well, you will have 100 in the numerator and 5 in the denominator if you divide by 25. And to calculate this, okay, let us try it out for the second example also, where R% is 25, or rather minus 25, since it is negative. What will you have in the numerator? You'll have this minus will cancel out. You'll have 2500 in the numerator. You'll have 100 minus 25 since it is negative here, or 75 in the denominator. You'll be left with 100 by 3, which if you notice is nothing else but 33.33%, and that is the value that you had got. So once again, the formula is very important. Moving on to the nullification case, which means, let's say if your salary grows by 10%, to come back to original, it should drop by what percentage? If you are thinking it should drop by 10%, then you are wrong. Let me show you how. Let's say your salary originally was 100 rupees. It grew by 10%, so it became 110 rupees. Now it should go back to the original. That means it should fall by 10 rupees. But this time it is falling 10 rupees on 110 rupees. This is not a 10% change. This is a 1 by 11 or a 9.09% change. As you can see, this is different from the 10% change. To calculate this, you can do it by this method, calculate the actual values, or once again, you can use the formula that you used above, minus 100R by 100 plus R%, which means that if you have to nullify a R% change, you can do it by minus of 100R upon 100 plus R percentage change. With this, I'd like to wrap up this session. Please provide feedback via Twitter at my Twitter handle @RaviHanda, or you can also email me on my mail ID, which is ravihanda@gmail.com. Thank you. And welcome to the part 3 session on percentage. You can reach out to me via Twitter. My Twitter handle is @RaviHanda. Today we are going to talk about successive percentage change. Well, to understand successive percentage change, you first need to know what it is. What it is, let's say a particular quantity increases by 10%, then it increases by 20%, then it increases by 30%. That is known as successive percentage change. It could be one of them is positive, two of them are negative. That also is successive percentage change. The problem is a lot of people make mistakes in something like this. A 10% change with a plus 20% change and a plus 30% change. A lot of people think that you can simply add them up. You can simply say that the total change in case of 10%, then 20%, then 30% is effectively 10 plus 20 plus 30 or 60%. But if that is what you think, you are wrong. Here is how you can solve these questions. Let's say if you have an A% change and a B% change and then a C% change, it is effectively given by X being your original value into 1 plus A by 100, 1 plus B by 100 and 1 plus C by 100. What I'm trying to say is, let's say if there was a 100 value which was 100, which increased by 10%, then by 20% and then by 30%. Then what will be the final value? Let's say you start with 100, 10% change makes it 110. You add another 20% to it. Now this 20% is not of 100 but of 110. That means you add how much to it? You add 22 to it, or it becomes 132. Then when you add 30% to it, the third and the final time, this is not going to be 30, it is not going to be 30% of 110, it is going to be 30% of 132. 30% of 132 is 39.6, which will lead you to the final value of how much is it? If it was 40, it would have been 172. So it is 171.6. As you can see here, 171.6 is not a 60% change, but a 71.6% change. You could have calculated this by the formula also, the formula that I have mentioned here. Let's see how. Original value you have taken as 100 into 1 plus 10 by 100 into 1 plus 20 by 100 into 1 plus 30 by 100, which if you notice carefully is nothing else but 100 into 1.1 into 1.2 into 1.3. And if you multiply this 1.1 into 1.2 into 1.3 into 100, do you know what value you are going to get? Yes, you are going to get the same value that you had got above, 171.6. From 100, you are getting to 171.6. That means your change was 71.6%. This idea of getting the final value by formula comes in most handy to you when you have two values. Let's say successive percent change of A% and B%. Then let's say if you have a 10% change and a 20% change. Either you can do it this way where you calculate all the entire values, or you could apply the above formula, or you can simply use the formula which is given here, that is A plus B plus AB by 100. If you use that, let's see what will you get. 10 plus 20 plus 10 into 20 by 100. And how much is 10 into 20 by 100? That is 200 by 100 or 2, which gives me the value of 10 plus 20 plus 2 or 32. As you can see, this is much easier than either of the methods. In the first method, you would have to do this much. First, get to 110, then 20%. In the second method also, you will have to do at least this much. You will have to multiply 1.1 and 1.2. Here, the value is very correct and you got it directly, very, very easily just by using A plus B plus AB by 100. Now, some of you might think, will this also work in the case of negatives? Yes, it will. Let's say, take off an example of a particular shop, which offers you a 40% discount, a 40% discount, and a 60% discount after that. Then, what is the net percentage change? We'll calculate it by, let's say, my original method of the values. From 100, a 40% change will take it to 60. Another 60% drop, that means a drop of 36 rupees on 60 rupees. See, originally we started with 100 rupees, 40 rupees discount took it to 60 rupees. Another 36 rupees discount took it to 24 rupees, which if you notice is a net of 76%. Now, let's do it by the formula, which is A plus B plus AB by 100. But you need to be very, very careful when you apply the formula A plus B plus AB by 100. These are discounts that we are talking about. So discounts are negative. So this will be minus 40, minus 60, and then product of minus 40 and minus 60, that by 100. Let's see what you get. Minus 40 and minus 60 is minus 100. Then minus 40 into minus 60 is 2400 by 100 or 24, which gives you minus 76. Minus 76% is your discount, which you had got by the original value. Excuse me, which you had got by the original value also above. So I highly recommend that you use this particular formula instead of going by the long calculative methods. If you have more than 2 values, well, then you can use the above formula. But do not do it by overall calculations. There is another thing which I like to tell you, that is the percentage changes are multiplicative in nature, which essentially means that if instead of A%, B%, C%, it was C%, then A%, and then B%, would your result change? No, it would still remain the same. Why? Because they are multiplicative. So let's say if a particular shop offers you 40% discount and 60% discount, whereas there is a rival shop which offers you 60% discount and a 40% discount. Which shop should you go to? Well, you can go to any shop that you like, because 40% and 60% and 60% and 40%, they are going to be exactly the same. The order of percentages does not matter. Please remember, the order of percentages does not matter. What matters is their values and whether they are positive or negative, that is, whether they are increasing or decreasing. With this, I'd like to wrap up this session. Please provide feedback via Twitter at my Twitter handle @RaviHanda, or you can also email me on my mail ID, which is ravihanda@gmail.com. Thank you guys.